All right, next in this unit, we're going to focus in on linear functions or straight lines. And essential to the idea of a linear function is the slope, which is also known as the rate of change of the line. So this is not new to you by any means. I assume that you've run into lines before and found equation of lines before, but we're going to go through a quick review of both the slope and how to find equations of lines. And this lesson is going to focus in on slope. So slope is usually denoted by the letter m. And for a non-vertical line, it is the ratio of the vertical change, which we call the rise, to the horizontal change, which we call the run. So if you see on this graph, I've got a linear function with 2 points, x1, y1, and x2, y2. To calculate the slope of the line, I figure out how much it rises, which is y2 minus y1, and how much it runs, which is x2 minus x1. And to find the slope, then I take the ratio of those two quantities. So that would be on the top, y2 minus y1, and on the bottom, x2 minus x1. Now, a lot of times students ask me, how do you know which is x2, which is x1, which is y2, which is y1? And I always tell them, actually, it's your choice. You can choose which point is point 1 and which point is point 2. And based on that, you get x2 and y2. Can you change them? Choose this one to be point 2 and this one to be point 1? Absolutely. As long as y2 and x2 go together and y1 and x1 go together, you are flying golden. All right, let's take a look at a few examples. Find the slope for each, then tell if it rises, falls, is horizontal, or is vertical. So example number 1 gives us the point 4, 5 and the point -2, -4. So I know my equation again is y2 minus y1 over x2 minus x1. And as I said up above, you can choose if you want this to be point 1 and this to be point 2, or this to be point 2 and this to be point 1 is totally up to you. Just be consistent. So just for fun, I'm going to switch things around and call this point 2 and this point 1. So this would then be x2, y2, and x1, y1. So when I fill these in, remember that y2 and x2 go together. So I'm going to take the 5 from my first one and the 4. So those are both from point 2. y2 is 5, x2 is 4. And then y1, x1, going to subtract them both. So subtract y1, -4, and x1, -2. Remember, minus minus actually gives me a plus. So when I equate this, 5 minus -4 gives me 9. And 4 minus -2 gives me 6, which gives me 3/2 as a reduced fraction. All right, so now we need to tell if it rises, falls, or is horizontal or vertical. So here's the way you remember that. If the slope is positive, which in this case it is, it's going to rise. My line rises. So just a quick sketch of this line. Here's my x and y axes. Rises means from left to right, it's going to go up to the left. Rising, positive slope, rising. Right, let's take a look at example 2. Again, I'm going to write down my equation just so I get used to it. I have it memorized, y2 minus y1 over x2 minus x1. This time I'm going to choose this to be point 1 and this to be point 2. It's up to you which direction you want to go. So when I put my numbers in, then y2 is going to be 3 and x2 is going to be 10 minus y1 is going to be 5 and x1 is going to be 4. So this gets me 3 minus 5 is -2 and 10 minus 4 is 6. Again, reduce my fraction and I'm going to bring the negative out front to make the whole thing negative. So -1/3. So this time I've got a negative slope. So that means my function is falling. The function falls. So quick sketch there too. Just to remind you what that looks like. My function is falling. That means as I draw from left to right, I'm going downwards, down to the right. This one goes up to the right, this one goes down to the right. Positive slope rises, negative slope falls. 2 more examples. Example number 3. So m equals y2 minus y1 over x2 minus x1. Just for fun, again, let's make this number 2 and this number 1. So y2, 8 over x2, 4, minus y1, 10 over x1, 4, gives me negative 2 over 0. Oh no, we can't divide by 0. Mathematical error. This tells us actually, so my slope is undefined. And this tells me I've got a vertical line. Remember that we said in our definition the slope is the rise over run for non-vertical lines? Well, for vertical lines, this is what happens. We get to divide by 0. So if you were going to graph this dude, what you'd end up with, we have 4, 8, and 4, 10, means we've got 2 points up here, right in a line, and when I connect them, I get a straight vertical line. Sorry, I'm going to do that in a different color. Straight line, vertical, with an undefined slope. So, is it horizontal, vertical? It is vertical. Last example. M equals, again, y2 minus y1 over x2 minus x1. You're never going to forget this. And it's up to you. I'm going to call this 1 and this one 2. So, y2, negative 2, x2, negative 3, minus y1 minus negative 2, x1, 6, and that gives me 0 over negative 9, which is equal to 0. Meaning I'm not rising. This is, by definition, then a horizontal line. So 0 on the top, horizontal line, 0 on the bottom, vertical line, undefined. 0 on the top, it's okay, we can do with that. It just gives us 0. 0 on the bottom, explode. Mind explodes because we're trying to divide by 0. So then if you tried to sketch this one really quickly, you'd have 2 points, so negative 2, or sorry, 6, negative 2, somewhere down here, and negative 2, somewhere over here. Connect them, should give you a straight across horizontal line. So, positive slope rises, negative slope falls. 0 on the bottom, undefined, is a vertical line, and 0 on the top is fine. That's just equal to 0, horizontal line. Now we're going to take a look at the idea of parallel and perpendicular. So, lines are parallel if and only if they have exactly the same slope. Again, let's do a quick sketch here for you. Two lines are parallel if they have exactly the same slope. Oops. The reason for that is a rise on this line and a run will look exactly the same, rise, run on the other line. Same amount to keep them parallel. Remember that parallel lines are two lines that never cross. So your rise is the same as your run, which gives you the same slope. On the other hand, lines are perpendicular if and only if their slopes are negative reciprocals of each other. Reciprocal means flip your fraction over. So for example, if my first slope is 1 over 4, then my perpendicular slope is going to be negative 4 over 1, which is just negative 4. So remember that any regular number, any integer value, is automatically a fraction over 1. So if you're wondering how to turn a negative 4 into the perpendicular slope, you have to put the 1 underneath to flip it over to get you 1/4. If I have my original slope as negative 3/4, then my perpendicular slope, flip the fraction over, 4 over 3, and make it positive. So the opposite of a negative is a positive. So a negative 3/4 have a perpendicular slope of 4/3. And just a reminder that perpendicular slopes cross at a right angle, perpendicular lines. That's the definition of a perpendicular line. So I'm not sure how well I'm going to be able to show that here in your little sketch. But the idea being, perpendicular lines cross at 90 degrees. So 4/3 and negative 3/4. And you can tell that this slope must be negative and this slope must be positive in order for them to be perpendicular. Okay, so are the following lines parallel, perpendicular, or neither? In order to find that out, you need to find each slope. So let's take a look at line 1, which goes through the point -2, 2, and 0, 1. So let's find the slope. I'm going to call this line 1, so this point 1 and this point 2, so I'm going to start out with -1 over 0 minus 2 minus -2 on the bottom. -1 minus 2 is -3, and -2 is +2. So my first slope, we'll call this M1, is -3 over 2. M2, okay, again, I'm going to call this point 2, point 1, so 3 over 2 minus -1 minus -4. 3 plus 1, 4. 2 plus 4, 6. And this is 2/3. So the slopes certainly aren't the same, because one is negative and one is positive, but are they perpendicular? So they're not parallel because they're not the same, but are they perpendicular? Well, to find that out, we can say M1 times M2 should equal -1. So if I take M1 times M2, I get -3 over 2 times 2 over 3 gives me -6 over 6, which does indeed equal -1. So these are perpendicular. Taking a look at the second example, example number 6, line 3 goes through 1, 2, and 4, -3, so let's find M3. So -3 over 4 minus 2 minus 1, and that gives me -5 over 3. For line number 4, M4 equals -2 over -1 minus 3 minus -4. So -5, and this gives me 3. Same slope, exactly the same slope. They must be parallel. So far, so good? Awesome. All right, so with linear functions, we talk about slope. With other functions, we can still find what we call the rate of change, which is just kind of the average slope between 2 points. So it uses the same equation, essentially, as slope, that represents how much one quantity changes on average relative to a change in another quantity. Units are important in this case. Usually this comes along with word problems. So we use the same idea. The difference is that our function in the middle may or may not be linear. So I might have a function that looks something like this. So it doesn't really have a slope in the same way that a line has a slope, but I can find the rate of change between 2 points, which would be the slope of the line that I would draw between those 2 points. So that's just the difference between slope and rate of change, is if I drew a line between 2 points on a nonlinear function, it would be the slope of that line. So, for example, in 1965, the diameter of a certain tree was 137 inches. In 2005, the diameter of the same tree was 141 inches. What is the rate of change in diameter of the tree over time? So we're going to use the same idea. And in this case, our time is going to represent our x value. So these are both going to be x values. And our diameter is going to be our y value. And the reason that we know that is because it's diameter of the tree over time. Over time suggests time is on the bottom, time is our denominator. So time is going to be our x, which usually goes on the bottom. So why don't we call this one x1, this one y1, x2, y2. Here we've got a picture of our tree. This is our x1, y1, x2, y2, and then we're just going to apply our slope formula. So our y2, 141 over 2005 minus 137 over 1965 You might need to type that into your calculator if you can't do that in your head, but 141 minus 37 is just 4. And 2005 minus 1965 is 40 years. So this is going to be 0.1. And now this is where the units come in, because we had each of these associated with a certain number of units. So my my y value on top was measured in 137 inches, 141 inches, so this is going to be 4 inches. And my x values were measuring in years, so this is going to be years. So my answer is 0.1 inches per year. So do keep track of those units. They are important for your answer. Units should be included in your answer for this kind of a word problem, inches per year. With that information then, they tell us, predict the diameter of the tree in 2064. So 2064, a lot of time has passed. So from 2005 to 2064, how many years would that be? Well, to find that out, I would go 2064 minus 2005. And that tells me 59 years have passed since 2005. Now in those 59 years, each year we've grown by 0.1 inches. So to find how much bigger it is than it was in 2005, I'm going to multiply 59 times 0.1 to find out how much have we grown by. So it should be 5.9 inches more than it was in 2005. Well, if it was 141 inches in 2005 and it's grown by 5.9 inches, we just need to add those. So 141 plus 5.9 tells me in 2064 my total diameter is going to be 146.9 inches. So you see how we reasoned that through? We figured out how many years had passed since 2005, and then figured out how much it had grown per year times the number of years to give me the number of inches it's grown, and then add that to my starting value. All right, one more example, and then it's your turn. A car uses 3 gallons of gas for 50 miles on one trip, and uses 9 gallons of gas for 140 miles on another trip. What is the average rate of change in miles per gallon? So again, this miles per gallon is telling us how to set up our slope equation, because the per is going to be our denominator, that's going to be our x's, and the miles, that's going to be our y's. So this would be my y1 and my x1, and this would be gallons x2 and y2. Then it's just a matter of setting up my slope. So y2, 140, over x2, 9, minus y1, 50, over x2, 3. 140 minus 50 is 90. 9 minus 3 is 6. If I reduce that or divide that, it gives me 15. And again, 90, 140 and 50, they were measured in miles. 6, that was the 3 gallons and the 9 gallons measured in gallons. So this gives me final answer in miles per gallon. Or you can write it out miles per gallon if you want, with the word per, like they did in the question. All right, it's your turn. Pause your video now. You try number 1 and number 2, then come back and we will work through the solution together. All right, here we go. Again, we're trying to figure out if these slopes are parallel, perpendicular, or neither. So let's find M1 is, I'm going to call this line 2, line 1, sorry, point 2, point 1. So point 2 minus 3.2 over negative 2.5 minus 4.5 is going to give me negative 3 over negative 7, or canceling the negatives, 3 over 7. That's my M1. M2, again, I'm going to call this 2 and this 1. So I have 0 over 10 minus 3 minus 3. And this is negative 3 then over 7. 3 over 7, not the same as negative 3 over 7. Not reciprocals of each other either. So this is neither. It's neither perpendicular nor parallel. All right, last word problem. After 2 months, a bamboo plant was 1.75 inches tall. After 8 months, the same plant was 12.4 inches tall. Find the rate of change in terms of inches per month. Predict how tall it will be after 1 year. So inches per month tells me my inches are going to go on the top and my months are going to go on the bottom. So if I have M, my average rate of change is inches number 2, 12.4, minus inches number 1, 1.75. Month number 2, 8, minus 2 is 10.65 over 6. And then I have 1.775 inches per month as my rate of change. Predict how tall it will be after 1 year. Well, 1 year, that's 12 months. And 12 months total, that's 4 months after the 8-month mark. So if I want to use the 8-month mark, then I have to add an additional 4 months times my 1.775 inches per month, which tells me from the 8 months it's going to grow another 7.1 inches. And it was 12.4 inches plus the 7.1 inches. That's going to get to be a pretty tall plant. 19.5 inches tall. So my two answers, box them so I can find them easily, especially since there are 2 of them. All right, that's it for this lesson. Good luck with the homework. Don't forget to summarize your notes.